Today's lesson is section 3.6, day 1, and it's all about the chain rule, taking derivatives using the chain rule. The chain rule is also known as the outside-inside rule. And the reason we need the chain rule can be defined by this example right here. If we have a function as sine, the derivative of sine we know is cosine. If we have a function x squared minus 4, we know that the derivative is just 2x plus 0. And if our function is x to the third, we know that the derivative is equal to 3x squared. But what happens when we combine these functions, as in the case of y equals sine of x squared minus 4, or in the case of y equals x squared minus 4 cubed? Here we have composite functions. So the chain rule helps us to take the derivative of composite functions, functions within functions. Now, this is a lot of definitions, and this is called, so the definition here using composite type terminology, you need to look at this and also maybe look at this in your book. This is called Leibniz notation, which is the other guy besides Newton who is credited with defining calculus. So take a look at, pause this video and take a look at this stuff, and we're going to move on to actually using the power chain rule. All right, so we want to take the derivative of the outside and multiply by the derivative of the inside. So it's called the outside-inside rule. All right, so I always start with take the derivative of the outside. Okay, the outside function is something to the third power. So when we take a derivative of something to the third power, we take that something, we multiply it by 3, multiply by the power, subtract 1, and we have the something squared. Our something happens to be the inside, which is x squared minus 4. So right now we've taken the derivative of the outside. All right, this says take the derivative of the outside using the power rule. The du dx is the derivative of the inside. Okay, so the derivative of the inside is 2x. That is our answer. We might choose to simplify it just a little bit by putting the 2x into the front. So we have 6x, x squared minus 4 squared as our final answer. Okay, so this is the final answer. Outside function, take the derivative and multiply by the derivative of the inside. A couple more examples using trigonometric derivatives and also using polynomials. All right, so now we have the derivative of the outside. The outside function this time is sine. So the inside function is again x squared minus 4. So the derivative of sine is equal to cosine. So we have the cosine of this something. All right, the something happens to be x squared minus 4. And again, we're going to multiply by the derivative of that inside something, which is 2x. So this is the derivative of the outside in red times the derivative of the inside. Now notice, and this is a huge mistake that people make, people being students, being you, always keep this angle for cosine and sine the same. The angle does not change. This inside is whatever it started with. Then we multiply times the derivative on the outside. A prettier way to write this might be 2x cosine of x squared minus 4. We try to keep the world as pretty as we can. So there it is. All right, example B. The derivative of tangent. Tangent is the outside. We're going to take the derivative of tangent, which is secant squared. So we have y prime equals secant squared of whatever's on the inside. Do not change this inside, 2x plus 3. Then we multiply times the derivative of 2x plus 3, which is just 2. So y prime equals 2 secant squared times 2x plus 3. All right, so this is taking derivatives using the power rule and trig derivatives. A couple more examples. Oh, wow. Sine squared. All right, first of all, I'm going to rewrite this equation, sine squared, because I think it's important to know, and it's important to know in this course, that sine squared of x is the same thing as sine x in parentheses squared. All right, so our outside function is actually the something squared. So we're going to take the derivative using the power rule first. We're going to bring the 2 to the front, keep the sign in the parentheses, and then subtract 1 from the power, so that just gives us to the first power. And now we multiply times the derivative of sine. So this is derivative of inside. The derivative of sine is cosine. All right, now if we write this simplified, we get the derivative equals 2 sine of x cosine of x. And we're finished with that one. So again, this is your derivative when you take the outside derivative times the inside derivative. And we use the chain rule all the time. There are always questions on the AP test using the chain rule. Okay, last example. This is an outside function of secant and an inside function of tangent. So always identify what's your outside function, what's your inside function. All right, so this one is a little bit tricky, but not really. That outside function is secant. So we know that the derivative of secant is secant of something, and tangent of something. Okay, now, don't make the mistake of messing up your something. Your something is tangent of x. And that's in both cases. I know it doesn't look pretty, but the real world isn't pretty. Anyway, so the inside function is tangent. Now we're going to multiply this times the derivative of tangent of x. The derivative of tangent of x is just equal to secant squared, correct? So we write down secant squared. By the way, I hope you answered my question when I said correct. You said yes. All right, now that is our answer. We really don't need to simplify it anymore unless you wanted to write it a little bit neater. Derivative of the outside function is secant, that's secant tangent, and the derivative of the inside function is secant squared. So all of that multiplied together is our answer. And that is lesson 3.6, day 1.